Hi, it's Anonymous, and today we're going to talk about free body diagrams. So a free body diagram, often written as FBD for free body diagram, is simply a representation of forces on an object. So say we have two people pushing a box. This person has long arms, and this person is pushing this box. Well, if we look at it from the side, we can simplify this three-dimensional object into a 2D one. And we know this person is pushing in this direction, this person is pushing in this direction. Now, one thing you need to do when creating a free body diagram is also establishing a coordinate system. So I'll just say this is the y direction and this is the x direction. So this is positive x and this is positive y. And what I want to find out is the direction the box will move and how fast it will accelerate in the direction that it's moving. Well, we first need to find the forces. Now, what I didn't tell you is that this person was pushing the box at a force of 10 newtons, and this person was pushing the box at a force of 15 newtons. Therefore, this vector should be larger, signifying the larger magnitude. Given that this vector is larger, and we're just going in the purely x direction, in this case we're going in the negative x direction, then the box will move to the left, or the negative x direction. However, I want to know how fast it will accelerate in the negative x direction now. Well, we know that force is equal to mass times acceleration. Well, I'm not 100% sure of the mass, so we'll just call this m for mass. So, what I should have said is sum of forces equals mass times acceleration. So, let's add up the forces. So we have 10 newtons going in the positive x direction, minus 15 newtons is equal to mass times acceleration. Well, 10 newtons minus 15 newtons is simply negative 5 newtons, and that's equal to mass times acceleration. Now, solving for acceleration, we divide both sides by the mass. So now we have negative 5 newtons over the mass is equal to our acceleration. Now, one thing we need to note is that the mass was not given. So in this case, all you can write is negative 5 newtons over some mass is equal to acceleration. However, say the mass is given and the weight of this box is 1 kilogram, then this becomes negative 5 newtons over 1 kilogram is equal to acceleration. Going over here, we then write acceleration is equal to negative 5 meters per second squared. Meters per second squared is acceleration because acceleration is measuring the change in velocity. The velocity is in meters per second, but given that we're looking at acceleration, that would be meters per second, or meters per second squared. So now we see that the acceleration is negative 5 meters per second squared, and this is a vector, So what really should be written is acceleration with a vector sign on top. Since we're going in the negative direction, and we have the magnitude of 5. Now one thing to note here is that you can check your answer always by looking at the most fundamental part of this problem, which is this formula here. Negative 5 newtons over the mass is equal to the acceleration. Well, this should make sense because as the mass gets larger, it'll be more difficult to push. Say the mass was 10 newtons. Sorry, 10 kilograms. If the mass is 10 kilograms, then the acceleration is negative 5 newtons over 10 kilograms, which is equal to negative 1/2 meters per second squared. This is 10 times slower than before. It should lead to another relationship. We can see here the acceleration and the mass are inversely proportional, meaning that if the mass increases by 10, the acceleration will decrease by 10, which happened here. I said the mass is 10 kilograms, increased from 1 by 10, and the acceleration decreased by 10. It went from negative 5 meters per second squared to negative 1/2 meters per second squared. So we're purely looking at the magnitude. That is what we have, and that's been a summary of free body diagrams. Thanks for watching.